Alright, so today's date is Wednesday, October 9th, 2019. We are doing slope from 2 points, slightly harder than yesterday, but again, if you know slope, then you are in good shape. Objective, quiet raise hand, who's got it? Yes, Emma.
Find the slope from a table and from 2 points.
There it is. So there's two parts to our objective, which generally means, and it does mean in this case, that we're going to have two types of homework problems. First type of homework problem is I'm going to give you a table and you're going to find the slope, and then next I'm going to give you 2 points and you're going to find a slope. They're very, very similar. First, quiet raise hand, what is the definition of slope? I had it written on the board. Charles?
Is it delta y over delta x?
It is indeed delta y over delta x. The change in y divided by the change in x. I'll take your card. Make sure that you have this memorized.
Oh, you had it.
I didn't realize I had it. Yeah, so that is a good definition of slope. There's another definition that is in all textbooks, and I will give it to you. You don't need to memorize this. Maybe this will help you. Hopefully it doesn't confuse you. And here it is. Another way that you can write slope is y2 minus y1.
I don't like it.
Write it down. You don't have to use it. I just want to give it to you in case you think it's useful. Divided by x2 minus x1.
I feel like we did.
So, yeah, it's in textbooks. I don't like it very much either because I like the definition of you just change in y, change in x, you're done. But if you want to use this one, this is saying this is your x2 and or y2 of your second point, whatever second point you want to do. So maybe I have a point y1 comma x1, and I have another point x2 comma y2. So these are 2 points that I have, and if you can convert these to y1 and x1 instead of 1 comma 2, then you can just plug them into the formula and solve. The reason this is in textbooks is sometimes kids just like to plug and chug. If you can memorize this formula, you just plug it in and you're done. But there it is. I am going to be using it once and then probably never again unless you guys want me to. So let's come down here to example number 1. What is the slope through the line 1, 3, and 7, 1? For this one, I want to use a graph to explain what's happening so you can connect what's happening with the graph versus what's happening with our equation. And then from there on, no more graphs. You should be able to do this every single time without a graph. So everyone graph these points, 1, 3, 7, 1.
Then draw a line through them.
And then please, yes, draw a line through them. If you want to do a sketch of the line, which means you don't need a ruler, then that's fine. If you want to actually make a real line, you will need a ruler. I am fine either way. All right, check up with the board, see if you got your 2 points correct. So 1 comma 3 is right here, 7 comma 1 is right here. You're checking, you're erasing, you're making sure that your work is correct. There are no questions at this point, and then you should be making a line through those. That is okay, that'll work. Right about there, and drag it right there. And please, whenever you're making your line, make sure that you have your arrows to tell me that it goes on and on forever and ever. All right. Go ahead and make your triangle. You should have a right triangle somewhere through lattice points.
So
There
does
are
it matter if it's like on top or bottom?
nope, it can be on the top or the bottom. As long as it's a right triangle, you're in good shape. So there's the triangle that Mr. Sindel drew. It looks like this. And then label it. If I'm going from the left to the right, did I go, if I'm starting at this point, I'll call this one point 1, and I'll call this point 2. I'm going from the left to the right. What did I do? Quiet raise hand. What is this one? What am I going to label it? What is the distance? Who has their card still? Oh yeah, Esha.
Well, you go down to.
So yep, you do go down 2. How am I going to label it? Is it going to be a positive 2 or negative 2 then?
I think it would be negative, but I'm not sure.
You are correct. It is negative 2. Perfect. Thank you. I'll take your card. And what about for this yellow? Am I going... Who has their card still? No one has their card. Oh, yeah, Jade.
6.
Is it a positive 6 or a negative 6?
Positive
It is indeed a positive 6. So you can just leave it 6, or if you want to be pedantic, you can say positive 6. Perfect. And then I'm going to come back to my definition of slope. So my definition of slope, everyone should write it down before I do it. Slope is equal to. Yeah, go ahead and write it down. Slope is equal to, you're writing it down, and then quiet raised hand, easy XP, who has it? Who still has their card? Larissa?
Delta y equals delta x.
It is indeed delta y on the top, and then on the bottom, delta x. And I try to color code this to make it a little bit more clear. All right, someone tell me what to fill in. What goes on the top, what goes on the bottom? One of these numbers, two of these numbers, Kira?
-1 or -2/6, but that you should simplify.
How can I simplify that?
It can be -1, -1/3.
Oh, there it is. Yeah, box it.
And there was another lattice point which I used, so you could have like just found -1/3.
Which lattice point? What was the coordinate?
It's actually right above where you wrote 6.
Right above where? Oh, right here.
Yeah.
So this coordinate is 4, 2. Yeah, I could have used that lattice point as well. So the reason that I chose not to use it was just to, I mean, you're 100% correct if you chose to use that lattice point, but I wanted to choose these 2 points because when we do this problem without a graph, we aren't going to know that a lattice point 4, 2 exists in between 1, 3, and 7, 1, unless you're really smart and you can look ahead. But using only these 2 points, I can come back here and say, okay, it's the change in the y's. So I'm just going to arbitrarily say, I'm going to do the first one minus the second one. 3 minus 1. That's the change in the y's. Does everyone see the y's are 3 and 1? I'm always going to do the first minus the second, or if you want, you can do the second minus the first. I just make sure you're always doing first minus second, first minus second. A lot of students will make this mistake of doing 3 minus 1 on the top, and then they'll just say, oh, well, I have 7 and 1 for the x's. I'm going to do 7 minus 1 on the bottom. No, that's not okay. You always have to do the first point minus the second point, so 3 minus 1, and then the first point minus the second point, so you should have 1 minus 7 on the bottom. Or if you want to go the reverse, do the second minus the first, second minus the first. That's where this formula comes from. So do not write 7 minus 1 on the bottom. That is incorrect. You need to write 1 minus 7. I'm always doing the first point minus the second point. The first y coordinate minus the second y coordinate. And then the first x coordinate minus the second x coordinate.
First y coordinate.
Second y
Wait,
coordinate
so
minus
you can
second.
get the slope by doing that?
Yep.
Without looking at a graph?
That's the whole point, yeah. We're trying to do it without looking at a graph. 3 minus 1.
So it's first y coordinate minus first x coordinate, no first y coordinate.
Y minus y, x minus x, just make sure you're going in the correct order. Go from left to right. The same thing minus the same thing.
Wait, but the negative was so it's x minus x and y minus y.
Yep, and that's where this formula comes from.
Oh.
Yeah, Charles.
Once we do the equation, the negative goes to the bottom.
Ah, yeah, so that's a good insight. I want to talk about that. Why does the negative go to the bottom? What does that mean? So when I simplify this, as Charles has seen, 3 minus 1, everyone shout out, is? Ooh, this one's going to be harder, though. Everyone's going to shout this one out. 1 minus 7 is? Negative 6, yeah. So you can think of this as plus a negative 7. If I have a positive and a negative, then I have to subtract 7 minus 1, and I take the sign the larger. That's where it becomes negative. 2 over negative 6, and then that reduces to, shout it out.
2 over
What? Negative 1/3.
Ooh, interesting. So some people are shouting out different answers that are all correct. So you could have said that this is 1 over negative 3, which some of you said. You could have said negative 1 over 3. You could have said negative 1 over positive 3.
Oh, it's the same.
All of those are the same. As long as I have one negative in there, these are all the same. You can either have the negative not touching either of them, the negative on the bottom, the negative on the top. Those are all the same. Charles?
Is it because if you divide a negative 1 divided by 3 or a negative 3 divided by 1, it'll still be negative?
That is the rule. Yeah, you have it. Good job. Cool. Other questions on example number 1? I'm going to show you a whole nother way to do example number 1. What if instead of doing 3 minus 1, we did 1 minus 3? What if I choose the second point minus the first point? What if I did, and this one you don't have to copy down, what if I did 1 minus 3? What would the bottom be if I did 1 minus 3, I'm doing the second point minus the first point. What would the denominator be? What?
7 minus.
It is indeed 7 minus 1. So I come back here and I say, well, I have to do the second point minus the first point, so 7 minus 1. Notice that I switch the 3 and the 1, which means I also have to switch the 1 and the 7. The 1 and the 7. And then from there, I solve again, and I say the top is going to be negative 2. The bottom is going to be 6. Negative 2 divided by 6 reduces to negative 1 over 3. I'm getting the same answer, negative 1/3, negative 1/3. I guess all of these are also negative 1/3 as well. The answer is negative 1/3. There are so many different ways to get there. You could graph it, but I want to try to make you do it without a graph. And there's a few different ways even when I don't graph it. So what I want you to do, actually, we have 3 examples. So let's do number 2 without a graph, and then you guys are going to do example number 3. How am I going to do example number 2 without a graph? Ulysses, do the numerator for us. Or actually, can you give us the formula for slope first? Let's base it there. Slope is equal to,
Like, the x and y, or which?
yeah, delta.
Delta y over delta x.
Perfect. And then you can do the next step if you would like.
It's like how you solve it.
You can just do the numerator, and then we'll let someone else do the denominator.
Okay. It's negative 4 minus 0.
Negative 4 minus 0. There it is. Everyone copy it down. It looks like Ulysses is starting with the first point minus the second point. So you have to keep that order whenever you're doing the denominator. You need to do the first x-coordinate minus the second x-coordinate. This one is tricky. I'm giving you a warning. This one, a lot of students will make mistakes on. That's why I threw it up here for an example. So be careful. Is there a quiet raised hand that can tell me how I'm going to find the denominator of this fraction? Emma.
Negative 5 minus 1, or 1 minus negative 5.
1, yeah, I'm going to write down exactly what you said. 1 minus negative 5. 1 minus negative 5. She's correct. Which is weird to think about. You got it correct. Good job. And I know that Haziel is tapping away furiously over here. The negative is still in there.
Wait, what?
I have a minus sign. Again, I have the minus sign because I need to subtract the 2, but I'm subtracting a negative. I have a negative here, so I have a double negative. Double negatives happen. And then, yeah, Eamon.
If you subtract a number, if you subtract a number using a negative, it will be like adding a positive number.
Yeah, and the rule that I like to say in my class is when negatives kiss, they become positive. Yeah, thank you, Eamon. So you will have double negatives about half the time, so be careful. You might have double negatives. Always say subtract whatever number I had. I'm subtracting a negative 5 in this case. And then I'm going to simplify. Who can do that for me? Wyatt?
It would be negative 4 above 6, which you would then want to simplify
Into?
to negative 2 above 3.
There it is. Box it. Notice that we didn't even need a graph for that one.
How all of them are going to be?
No, the back half is going to be a little bit different, but very similar. You guys, right? Oh, question.
So, I'm gonna mess up so much when we have to do negative 4 minus 0 over the other numbers. What's like a really easy way to be able to remember that kind of thing?
The easiest way, if you think that you're going to make a mistake, is to memorize this formula. If you're just plugging in y2 and y1 and the negative is still there, that's how you can remember if there's a double negative or not. That's why this formula is up here, because if you have it memorized, then it's as simple as saying, well, I'm going to say that this is my first point, this is my second point. Let me show you this formula, because I said I would show you once and I never did it yet. So another way of doing this, and this again is totally optional if you want to write this down, if you think you're going to make a mistake, I highly recommend writing it down, or at least paying really good attention. Slope is equal to y2 minus y1, all divided by x2 minus x1. So I'm going to say arbitrarily, randomly, that this is going to be point number 1, and this is going to be point number 2. I could have said the other way. I could have said this is point number 2 and point number 1. If this is point number 2, what is the y-coordinate of point number 2? The y-coordinate is 0. I plug it in. This is now equal to 0. This y2 is a 0. And then I have to copy down the subtraction sign, subtract. And then y1. Okay, that means I'm talking about point number 1 and the y coordinate of that 1. So I come back over here and I say that this y1 is negative 4. So I say negative 4. Now that's where the double negative comes from. Again, it's as simple as plugging in. I can say, and if you're not paying attention, you can just go to example 3 because that's where we're doing next. And then the next thing I say is, okay, I need x2. x2 says the x coordinate of the second point. This is the second point. Here's the x coordinate of the second point, negative 5. So I write down negative 5, and I need to copy down the negative because it's subtracting the x1. Subtracting x1. Well, what does x1 mean? I'm looking at the first point, so the first point, and I'm taking the x coordinate of that first point. That's going to be 1.
Okay.
Thank you.
Yeah.
It's literally plugging into the formula.
Yeah, that was helpful, but so you do x minus x, y minus y, and that's how you set up the problem every single time.
Every single time. Yep.
Okay.
And then from there you have to use the double negatives, make a kiss, or they kiss and become positive. So it becomes 4 over, and then it's going to be keep, change, change. So negative 5 plus negative 1 is negative 6. And again, you simplify that to negative 2 over 3. Same answer.
Okay.
All right, you guys should be doing example number 3. And if you want, you can try doing example number 4 on the back. Although, even if you're aiming and you did everything like within 2 minutes of class, you still need to copy down how I do example number 4 because it will set you up later. All right, good luck. You can work with people around you. All right, I'm starting with slope. Who can give me slope? What? Give me the definition of slope.
Slope equals delta y over delta x.
Delta y over delta x. Did you want to do one of the halves?
Sure.
All right.
And then the numerator would be, I got 3 minus negative 7.
3 minus negative 7 in the numerator. Perfect. Well, I like showing the work because it's 3 minus and then negative 7. It is eventually going to change to a plus, so I just like showing the work for the notes. Larissa.
The bottom was negative 5
Minus negative 1. Perfect. Kira.
I have a question.
Oh, yeah, one of these.
I don't. It's literally what you're doing is y1 minus y2. So it's more confusing. I feel like to write it delta y because like what is that even?
The change in the y. How much did y change? Y went from 3 to negative 7.
But
So to go from 3 to negative 7, I have to subtract them. The change is always a subtraction
delta
problem.
y is just representing 1 y not 2. I don't know.
Okay, so maybe you don't like delta y over delta x. You don't have to use it. I'm not going to force you.
I just thought that was kind of
Do you prefer the other formula where you do this one minus the other?
Because like that actually shows what you're actually doing. Like delta y, it seems like it's just like one of the numbers.
Okay, yeah. Then I would definitely recommend using that formula.
Okay.
All right, so we have the problem set up good so far. Can someone add, subtract, and then simplify, do all the math for us? Kira?
10 over negative 4.
Negative 4, because it's going to be 3 plus 7 and negative 5 plus 1, and then that reduces to... Kira, you want to reduce it as well?
It reduces to 5 over negative 2.
There it is, 5 over negative 2. If you got positive 5 over 2, see if you can find the mistake. Usually if you...
So wait. I just... Wait. Oh, you did a different order than me.
So if I do it the other way, if I do the second one minus the first one, then the way that that would look is it would be negative 7... Sorry, let me do this in green. The other order would be negative 7 minus 3, all of that divided by negative 1 minus negative 5. If I do it this way, then I have to do a keep, change, change, and that turns into a negative 10 on the top, and on the bottom I have negative 1 plus 5, which is a positive 4, and that still turns into a negative 5 over 2. There are two ways of doing this one. Both of them get you to -5/2.
So really, the order doesn't matter a ton.
Nope. As long as you're going the same direction each time, you're good. If you go one direction one time and then the other direction the other time, that means that you're going to be just a negative error. So if you ever get an answer that's 2 and you got -2, it's because you didn't follow the same direction. All right, so we're going kind of slow, but I need to get through example number 4. What is the slope that contains these points, of the line that contains these points? For this one, it's kind of easier. You get to pick and choose whichever 2 points you want to do, because we know how to do it with 2 points, so just choose, I'm going to choose that one, this one, and that one. Or I could choose this one and this one. Or I could choose this one and this one. Those are my 2 points. Same thing. Go. But there's an easier way that actually shows a pattern. Whenever you have a table, you have a pattern that you can do. Notice that if I'm always moving to the right, which is usually how we graph things, what is the change? How much is the x changing? Each time x is changing, is it going up or down? Who's seeing it? Ulysses?
It's going up by 2.
I'm going +2. +2. Everyone write this down. +2. On the table, I'm going +2, +2, +2. I'm always moving to the right. On the bottom, what is my pattern? My bottom, I'm changing by what each time? Wyatt?
+3.
+3, +3, +3. The definition of slope, and again, maybe some of you don't like this, but slope is simply the change in y divided by the change in x. Well, what is the change in y every single time?
3.
The change in y every single time is +3. The change in x every single time is +2. There's the answer. 3/2.
And that's all you have to do.
That's all you have to do. It's even easier. Although you can use the old formula and just choose 2 random points, this one is kind of cooler because it also sets you up for a future lesson. Because in the future, I'm going to tell you, find something with an x coordinate of 0. And I'll give you -2, 2, or 2, 8. And you have to use the pattern of adding 2 each time until you can get to 0. So this is really smart, being able to find the patterns on the top and the bottom. I would prefer this method. Let's try another one in example 5, then I'll let you loose for, oh, there's 2 5s, as Eamon already pointed out. This should be example number 6. Let's do first example number 5, and you can do the second example number 5. So, what is the pattern? What am I adding each time for the x's? Or maybe subtracting? What am I doing each time, Larissa?
Adding 5.
+5, +5, +5. Thank you. And what about for the y's? What am I doing each time, Ulysses? Subtract 4, subtract 4, subtract 4. Which means, if I define slope as the change in y divided by the change in x, what is my slope?
Are we ever gonna have to do like what happens like when the graphs aren't the same?
Yes, you will. Like, what happens if it was -4, -4, -3?
Yeah.
Yeah, those are types of questions that I ask you. Is it linear? These are linear because the pattern holds.
Oh, I remember.
If the pattern does not hold, it is no longer linear. All right, so can someone give me my answer? What is my slope? Kira?
-4/5.
-4/5 is the correct answer. Thank you. And then you guys can do second example number 5, which is really example number 6, and then you'll be done.
Okay, everybody, this is Wyatt filling in for Mr. Sindel on example number 5 dash, basically number 2, but it's really example number 6. So first, you gotta find the change in the table so we can find the pattern, which is +1, +1, +1. Then we gotta find the change in the y on the table. Excuse my bad handwriting. So this would be a +3, +3, +3, and then we have to write out our slope equals delta y over delta x, which is the change in y above the change in x, and we see that our change in y is positive 3 and our change in x is positive 1, so it'll just be 3 over 1, which is really just 3. And box your answer.